You know, the whole idea of flying cars, it's not science fiction anymore. It's really happening. We're on the brink of a whole new era in how we travel around our cities. But as we start looking up at the skies, there's one huge question we have to answer first. And it all comes down to the science of what's actually powering these incredible machines.
So let's just cut to the chase, right? We see these amazing futuristic aircraft, and we've got to wonder, are the batteries safe? I mean, really, can we trust them? It's probably the single most important question we need to answer before this technology, quite literally, takes off.
And to figure that out, we're not just guessing. We're going straight to the experts. This entire analysis is based on a massive safety report from some real heavy hitters, the UK Civil Aviation Authority and the brilliant battery researchers at the University of Warwick. They've done the hard science, so let's break down what they found.
Okay, first things first. What exactly are we talking about here? You'll hear the term eVTOL thrown around a lot. It just stands for Electric Vertical Takeoff and Landing Aircraft. Basically, think of them as quiet, super efficient electric air taxis. They're poised to completely revolutionize how we move through our cities. And the component making this all possible is something you already know well, the lithium-ion battery. But, and this is a really big but, we are not talking about the battery in your phone. These are massive, high-performance power systems. And with that kind of incredible power comes a unique and very critical challenge. And this brings us right to the core safety issue, the one thing that engineers and regulators are absolutely laser-focused on. It's a phenomenon with a name that sounds just as intense as it is: thermal runaway. So what on earth is it? Well, put simply, it's a vicious cycle. Imagine a fault inside the battery causes it to get a little hot. That heat kicks off a chemical reaction. That reaction, you guessed it, releases even more heat, which speeds up the reaction, which releases more heat. You see where this is going. It's a positive feedback loop, a runaway train that can spiral out of control really, really fast. This chart here shows you exactly what that looks like. You can see how the temperature kind of slowly creeps up at first as the initial reaction gets going, but then, boom, it hits a critical tipping point, right there around 180 degrees Celsius, and the process just takes over. It becomes self-accelerating. The temperature absolutely skyrockets in a tiny amount of time. That's thermal runaway in action. And when I say skyrockets, I am not kidding. During thermal runaway, a single battery cell can get hotter than 1,000 degrees Celsius. To put that in perspective, that's hot enough to melt aluminum. So, yeah, you can see why preventing this from ever happening is priority number one.
Now, the good news is that these things don't just happen out of the blue. There have to be very specific triggers that kick off this dangerous chain reaction. So let's take a look at what those are.
The report groups these triggers into three main buckets, what they call abuse conditions. Now, that sounds a little harsh. It doesn't mean someone is intentionally trying to break the battery. It just means something has pushed it way outside of its safe operating limits. And those three categories are mechanical, electrical, and thermal.
So what does that actually mean in the real world? Well, mechanical abuse is pretty easy to picture. That's physical damage from a crash or a hard landing. Electrical could be something like overcharging the battery or an internal short circuit. And thermal could be caused by something as simple as the cooling system failing, letting the battery get way, way too hot.
Okay. So we get the problem, and we get what causes it. Now for the most important part, the solutions. How are engineers actually designing these aircraft to be safe? The answer is all about a multi-layered defense strategy.
And that strategy starts right down at the level of pure chemistry. This is where engineers face a really critical trade-off. You've got two main battery types here. NMC batteries pack a ton of energy, which means longer flight times, which is great, but they're not as thermally stable as the other type, LFP, which are inherently safer but give you less range. Because performance is so important, most designs are using NMC, which just means their safety systems have to be exceptionally robust.
And that is exactly what they're doing. Safety isn't some afterthought here. It's a core principle that's woven into every single layer of the system. We're talking from the individual battery cell all the way up to the entire aircraft design. So what does this web of defenses actually look like? Well, it's a whole suite of preventative technologies. For instance, you've got shutdown separators that can stop the chemical reaction cold if a cell gets too hot. There are current interrupt devices, which act like super smart fuses. And watching over all of it is the sophisticated battery management system, or BMS. Think of it as the brain, constantly monitoring every single cell, ready to stop a problem long before it can ever escalate.
But let's ask the tough question. What if, against all odds, every single one of those preventative layers fails? What happens then? Well, you'd better believe there's a detailed, structured plan for that, too.
And they're not starting from scratch here. Experts have taken years of lessons learned from dealing with electric car fires on the road and have adapted all that knowledge into a specific custom-built emergency response plan just for eVTOLs.
And the plan is crystal clear. Phase 1 is all about saving lives, immediate evacuation of everyone on board. That's the absolute first priority. Phase 2 is containment. Firefighters get the scene under control and stop the fire from spreading. And finally, Phase 3 is disposal. The aircraft is safely quarantined to manage any risk of the fire reigniting. It's a methodical, step-by-step process.
So as we bring all this together, what's the big picture? It's all about building confidence. Confidence in this new technology that's founded on incredibly rigorous science and planning.
You know, this quote from the report itself really says it all. This isn't just guesswork. It's about creating a foundational framework to understand, manage, and be prepared for the risks. In other words, it's all about being proactive, not reactive.
So let's just boil it all down. The risk, the fear you might have, is of these uncontrollable battery fires. But the reality, according to the experts, is that this is a well-understood scientific challenge, and it's one that's being met with multiple layers of preventative tech and detailed, well-rehearsed response plans.
Which leaves us with one last thought. When you see this depth of research, this level of detailed planning, and this multi-layered approach to safety, you start to realize the question isn't really if we can do this safely. The real question is, how soon are our cities going to be transformed by it?